Hey guys, today we're going to be making a program that detects fake news with Python. If you have any questions, then write them down in the comments or email me at codefeet@gmail.com. So to create this, we're going to need to first download a dataset which has a long list of news headlines and all their sources to it. Some of them are fake and some of them are real. This is a list we're going to test our program with. The link for this is going to be in the description, and you're going to have to download it and save it onto your files. And you're also going to need to install some libraries with pip, so run this line onto your terminal. I'm just going to write it here. Pip install numpy pandas and that. So just run this into your terminal and it will download all of these libraries for you. And we're also going to be running, and yeah. So now we're going to first need to start off by making all of our imports. So I'm first going to start off with, just going to write a comment. So I'm going to start off with writing import pandas as PD. So this is a package. This package is used for data science and data analysis and machine learning tasks, which is exactly what we're going to need to be dealing with. And then we're going to have to import itertools. And this module will provide us with various functions that work on iterators. Then we're going to need to write So the train test split function is used for splitting data arrays into two sections. Now we're going to write so the feature extraction function can be used to extract features in a format supported by machine learning algorithms. Following on the TF-IDF vectorizer function, this transforms text to feature vectors, and that could be used as an input to the estimator. And I'm going to explain a bit more on that later on when we actually need to use it. So the passive-aggressive classifier works by responding as passive for correct classifications and responding as aggressive for miscalculations. Overall, this means that it's going to remain as if there were correct answers, and also it's going to respond if there's any miscalculations. And then finally, so this is a variable we're going to need to be using later on, so we can make our percentage of the accuracy from the data set. Now let's start off by reading the data into the data frame. So for this, we're going to just need to write df equals pd dot read underscore csv. And then here you're just going to need to copy out the path name for the file which is the dataset. So there you go. And now we're also going to need to get the shape and the head of the data, which is just going to find out the number of columns and rows in the data frame. So here I'm going to write df.shape and df.head. So that really simple is just going to get the look of the file. Now we're going to go ahead and print out the labels. So this is very important because it's going to print out the results, which ones are fake and which ones are real. Now we're going to split the dataset into testing and training. So train and test splits the data into two sets, a training set and a testing set. There's 80% for training and 20% for testing, and we're going to have two sets of them, the X and the Y. So you're going to train the model using the training set and set the model test the model using the testing set, which is quite simple. So let's split the data set. Okay, so like I said, this is just splitting it all up and working out the labels and the sizes and stuff like that. So now we're going to initialize the TF-IDF vectorizer. I spoke about this a bit earlier on, and I'm just going to go a bit more in depth. So this transforms text to feature vectors that can be used to input to estimators. The TF is the number of times a word appears in a document, and the IDF, inverse document frequency, are the amount of words that occur many times in the document. So the IDF measures how significant a term is used in the text. So we're going to need to make a variable for this first. So and here I'm going to write now here you see me using stop words, and these are the most common words in a language that are going to be filtered out before processing the natural language data. So we're going to disregard any words and terms with a higher document frequency of 0.7. Now we're going to also need to fit and transform the train test and the transform test set. So we're going to write so we're just going to be fitting and transforming the training test, doing the same bit for the testing one. Okay, so the fit method is calculating the mean and variance of each of the features present in our data. And then the transform method is going to be transforming all the features using the respective mean and variance. Now we're going to initialize the passive-aggressive classifier, and then we're going to fit this onto the TF-IDF train and the Y train. So here I'm going to write PAC, which is an abbreviated term for passive-aggressive classifier, and then pack.fit. We're going to fit it in now. Okay, and now finally we're going to need to use all of this to make a prediction, which is what we want, an accuracy percentage of how true the data set was. So I'm going to write Y period. So I'm making a prediction. Pack.predict. So we're going to predict it from the testing. And then we're going to make a score for this first. Accuracy score. And we already made this variable up here. And for that one, we're going to use the Y test and use the Y prediction. And then we're going to need to print this out as a percentage. So we're going to write F accuracy around to do the score times 100 to 2, and then just put a percentage. And I'm going to need to add a percentage over there. And there you go. I'm just going to put a label onto this. Predict. Okay, there you go. So now we're going to save this, and we're going to go onto the terminal. And there you go. So the accuracy of that data set, which we've just been testing out on, it was 93.05%. So I hope you enjoyed this, and you can be doing a lot with this, try and get out with different articles, I guess, and adding, maybe making a graph out of it. And yeah, I hope you enjoyed this and found this fun. Thank you for watching.